Hello everybody, my name is Ken Riley, and I welcome you to the next exciting video on the origins of gold, part 6. Another interesting thing is when they talk about the quartz coming up in hydrothermal events. Quartz does not dissolve in hot water. Your glass, when you put hot water in a glass, even 1,000 degrees hot water in a glass, it will not dissolve it, because quartz does not dissolve in water. Now, what these same chimpanzees were getting mixed up, they were observing certain compounds of silica. You know, they talk about water glass, okay? They saw water glass coming up in water. Water glass is sodium silicate. Sodium silicate is not quartz. It's a compound of sodium and silica. Water glass is not quartz. Water glass will come up and it'll go into fissures and whatever, but you can't confuse that with pure quartz. Pure quartz is not dissolvable in water. Okay, so what is really going on with the magma? If it's not hydrothermal events, hydrothermal water only gets up to about 850 or 860 degrees. That's not hot enough to melt metals or silica or anything like that. It's just not hot enough. So how are these elements coming up? Now, if you have very fine particles of gold or silver or some kind of metal, really, really small microscopic flakes down below, when that hot water comes up, it will bring up gold and silver and different things because it's already small particles and it's just riding on a hot fluid, just like riding down the river, but it's just like going through a river. But those hydrothermal waters are not dissolving the gold from a mass. So what's really going on? There is no such thing as magma, which is mineral in nature. It's metallic. Magma is metallic. All magma comes from the heat of the core, which is at close to 10,000 degrees Fahrenheit. That's your iron and your nickel. When those hot core elements come in contact with some of the other elements, doesn't matter what they are, sulfur, quartz, metals, even tungsten. Tungsten has the highest melting point of anything on the planet. It's like 6,500 degrees Fahrenheit. The core readily melts tungsten and brings it up as an ore. Now, how does it happen? Very simply, you have the core. This is your iron and nickel. This is at 10,000 degrees Fahrenheit. Now, as the Earth exerts pressure on the core, either from like land will actually go down to the bottom of the ocean and increase the pressure down there. That increases pressure on the core. So you have the Earth, as it continues to cool, exerts pressure down on the core. Well, you cannot compress the core. If you can't compress the core, then it's got to start coming up, making its way to the surface. As this core is compressed, somewhere these elements have to come out of the core and to the surface. Now, as your iron and nickel are coming up through these layers. You've got gold, you've got silver, you have all these different, you have silicon, you have all these layers that were formed as the Earth cooled, and as the 10,000 degree iron and nickel come up, they begin to melt through these different layers of elements and draw these elements up with them. They're melted and drawn at the same time. Now people will say, oh, but minerals are magma. No, they're not. Granite is not magma. It's not a primary heat source. It's a secondary heat source. All granite is metamorphic. It is not igneous. All granite is metamorphic. In fact, all magma outside of iron and nickel is metamorphic. It's being acted upon by the core. So all magma, except for iron and nickel, is metamorphic. It's been changed by heat. The only thing that is igneous is iron and nickel from the core. Okay, so sometimes you'll have an event where you'll have a solidified mass of silicon here, or what they call quartz. You have a mass of it right here as the iron comes up to this solid layer of quartz. It's drawing up gold and silver and a lot of different elements. It's actually drawing those up with it. Somebody wisely said, gold rides an iron horse. All gold comes from iron. It's the iron that melts it down and draws it like welding something, or just hot drawing through flux or whatever. The iron melts the gold, silver, whatever you're looking for, and draws it up through this chimney. Now, if it impacts a really, really thick, solid layer of quartz, it'll sit here. You can't get through it. It's too massive. It's too thick. So it'll sit here for a long time, and as it sits here, it's feeding heat up here all the time through this chimney. The quartz begins to melt. And as it melts, you have convection of the iron and the quartz and the gold and the silver. You have a convection exchange from the iron into the quartz or silicon. As it's slowly melting through this massive layer of quartz, you have a convection or rolling effect of the iron into the quartz. And that's where you get the exchange of gold from the iron to the quartz. It's actually a convection exchange. It's sort of like in welding. Welding wire or welding rods have a certain amount of silicon in them, 8 or 9 or 10% silicon, because the silicon is a fluxing agent. It makes the steel or the nickel rod or whatever you're using for a rod or wire as you're welding, it makes it flow because it's a flux. So you're getting a flux exchange from the iron into the quartz, and after a while this eventually melts through the quartz layer and comes out as maybe a ridgeback, or it could actually be a volcanic plug. People look at it and they say, oh, look, the gold came from quartz magma. No, it didn't. It came from the iron. The quartz drew or fluxed the gold out of the iron, and when the pressure finally broke through to the surface, the quartz came out, or it came up as a chimney of quartz with gold in it because of what the iron put there. That's where your gold comes from. All gold comes from iron. Now the fact that you you find it in quartz, or you'll see stringers of quartz in granite, like around the Catherine mine or something, a lot of fractured little stringers there. But you're always seeing these fractured stringers of quartz, but you usually find either a small percentage or a large percentage of iron in with the quartz. You always see iron in there, and a lot of times copper. So that's where we're going to leave it for this week. We're telling you exactly where the gold comes from. Now you have to understand this, or you can't build a foundation for how to spot gold in the field. You can spot it usually if you look for the red. In 9 times out of 10, your gold will be associated with either a basalt, that's an iron matrix, or what they call hematite, which is rusted iron. But usually it's the rusted iron where you find it, because the rusted iron or hematite, the iron, which was probably a form of basalt at one time, it was acted on by water, some weak acids, converting the basalt into iron. And we'll show you that in some future discussions as we go along. We'll show you how to spot gold in the field, even right alongside basalt. It's there. And we'll explain how it's getting out of the basalt and into the country rock, or the rock debris running right alongside the basalt ridge or dike, or whatever you want to call it. So that's it for this week. And remember, my name is not Jeff. I am not Roger from Oz. I'm Ken from Copperland. And like I always tell you, gold turbine products that we're designing and building will transform you magically from a 90-pound gold panning weakling into a beast of a miner. Now, if you want to be a beast of a miner, you want to get that gold, stay tuned. I'm going to show you how to get it. So, take care. We'll see you out in the gold fields, and we'll catch you next time on the next video. Bye for now.